Hi all. So in the second video of this playlist, I'll be explaining you guys like what is a decision tree and how it works actually. So decision tree, as from the name itself, it is quite obvious. It's a tree-like structure. So the output of this algorithm is a tree-like structure, which is generally used for classification, but there are some methods to use it for regression as well. And most of the times when we say like you are using a decision tree, it's mostly a binary classification, but there are ways to go to like multi-label or multi-class classification also using decision tree. Okay, so I'll just go to the steps which we need to actually model a decision tree. So so one is like we select a training data, okay, which we want to evaluate. Okay, and then I'll be explaining you guys like what are the calculations involved in training a decision tree, and then we need some test data on which we'll evaluate like what is the performance of our decision tree. Okay, in case of classification we generally go by the accuracy measure, but we'll discuss later in later videos like if uh, data is biased and the classes are not equally distributed, then accuracy might be something misleading, so we'll look at other matrices which we'll use. Okay, so there are multiple algorithms. I just have named a few which are generally used, but there are multiple algorithms to actually train a decision tree. When we say algorithms, it is actually the decision of like which feature or which variable should start the decision tree, how we split the data. So there are two theories behind it. The one is information theory and another approach is the Gini index. So first we'll be discussing the information theory one. So when we are actually splitting the data based on information theory, as we assumed, we have two classes, P and N, and we have like S number of samples in our training data. Okay, and let's say there are small p number of samples for the capital P class and small n number of samples for the capital N class. So the total information is calculated. So this is the capital I, which is total information. It is calculated based on how many samples are there in class negative by total number of samples, how many are there in class positive by total number of samples, and a log of it. So this is the total information we have. Okay, and this is the information we call something which is it's before the split, because we don't have a data splitted, we have the complete data set. Okay, now there is something which is called information after the split. You can see the formula, it's the summation of the values. So this ti comes from the features, how many values are there in a feature, but it will be explained later when we go through an example. Okay, and the gain we are getting from a particular variable or particular feature is the information before split minus the information after split. Okay, so we are taking a very simple data set which is like some bank has to give classes to their customers, let's say class A, B and C. So I'm taking a complex example here, not the binary tree one, but I am taking three classes. It's perfectly okay because the algorithm, the operations of the algorithm will not change a lot. Okay, so they have features like whether the person has his own home or not, married, gender, employed and credit rating. Okay, so let's go through the calculations. So we have total 10 samples. We have class A 3 times, B is 3 times and C is 4 times. So you have information before the split. Okay, and let's say we calculate it on the very first variable, which is whether the person has his own home or not. So for the values yes, we calculate the information gain, and for the values no, we again calculate the information gain. Okay, so once we have this information gain, in this case it is 1.52 for both of them, and you have 5 samples for both the categories. So in that case you just make a summation, you take an average of these two, otherwise we could have taken the weighted average. Okay, Similarly, I have calculated for other variables as well. And we have information before the split, which is constant, and we have after split. And it says that it makes sense to split the decision tree on gender because we are getting the maximum information gain in terms of gender. Okay. So once we split data based on gender, we find that, okay, if the gender is male, it's always class B. Okay, so we can remove this variable and then we perform all these steps again with the reduced data set. Okay, now for the reduced data we have just 7 samples. We again go through this process, and in the second case we get the maximum information in terms of married. Okay, so in case of married you just have 0 information after the split. So the same formula I minus x, you are getting the maximum gain in case of this feature. So your decision tree will look like this, with if the gender is male it's class B, and if the gender is female and married it's class C, if not married it's class A. Okay, again we have a similar algorithm for Gini index. In Gini index you don't take the log, but it's the summation of all the probabilities. Okay, and if we calculate it based on the probabilities, again we are getting a similar result. We are getting the maximum gain in terms of gender. So both the algorithms in this example are giving pretty much similar results. Okay, I think that's about it on decision tree. So what I'm thinking is I'll upload daily one video on how this algorithm work, and I'll share this presentation in the description. I'll just upload it on my GitHub and we'll share the link with you guys. And what I'll do is, like, for 6-7 days I'll share all the algorithms, and one day I'll just go through all the codes and we'll share those codes also on GitHub. Okay, I hope this video was helpful to you guys. Do like the video if you like the content and subscribe to my channel. Thank you guys.